Have you ever heard of Cri du Chat Syndrome? It's a rare genetic disorder, also known as 5p deletion syndrome, caused by the absence of a portion of chromosome 5. The name Cri du Chat translates from French to cry of the cat, referring to the high-pitched, cat-like cry that is a distinctive feature of infants with this syndrome. Other common characteristics include developmental delays and intellectual disabilities. It's a complex condition that can vary significantly among affected individuals. The good news is, recent advancements in genomic technologies are providing fresh insights into the molecular mechanisms that contribute to Cri du Chat syndrome. This new understanding is not only helping us to comprehend the pathogenesis of the disorder, but also opening doors to potential therapeutic strategies. So what exactly causes Cri du Chat syndrome? Let's delve into the mechanisms. Opening. The primary cause of CDCS is a deletion on the short arm of chromosome 5. Moving forward, let's delve into the mechanisms of Cri du Chat syndrome or CDCS. This rare genetic disorder is primarily caused by a deletion on the short arm of chromosome 5, appropriately named 5pe. This deletion is not typically inherited but occurs spontaneously during the formation of reproductive cells or in the early stages of embryonic development. The size and location of this deletion can vary among individuals affected by CDCS. This variation accounts for the wide range of clinical presentations seen in those with the syndrome. The deletion results in the loss of critical genes within the affected region. Notably, one such area is the cat-like cry critical region, or CCR, which contributes to the syndrome's most identifiable feature, a high-pitched cat-like cry. However, the deletion of genes is just one part of the puzzle. Alongside this, the syndrome also disrupts key developmental pathways. These disruptions alter the normal course of growth and development, further contributing to the syndrome's symptoms. Moreover, the deletion leads to altered gene expression profiles. In simple terms, the way genes are turned on or turned off is changed. This change affects how the body's cells function, influencing everything from physical development to cognitive abilities. But it's important to remember that the deletion on chromosome 5 is not the sole determinant of the severity or the exact manifestations of CDCS. Other genetic abnormalities can also play a role. The interplay between these genetic factors and their impact on the body's developmental processes makes CDCS a complex and multifaceted disorder. In summary, the mechanisms of CDCS are a result of a deletion on chromosome 5. The loss of critical genes, disruption of developmental pathways, and altered gene expression profiles. Each case is unique and multifaceted due to the variation in deletion size and location and the presence of additional genetic abnormalities. Closing. These disruptions lead to a variety of clinical manifestations. Curious about what they are? Individuals with CDCS exhibit a spectrum of clinical manifestations. This spectrum runs the gamut from developmental delays to congenital heart defects, and the severity of these symptoms can vary greatly from one individual to another. Developmental delays are a common manifestation of CDCS. These can encompass a range of challenges, including difficulties with gross and fine motor skills, cognitive development, and language acquisition. Intellectual disabilities are also prevalent, with many individuals with CDCS requiring ongoing support and accommodations to navigate daily life. Next, we delve into the distinctive physical traits often associated with CDCS. These can include microcephaly, where the head is significantly smaller than typical, low-set ears, and hypertelorism, which is an abnormally increased distance between the eyes. Congenital heart defects are another feature that may be present, posing additional health challenges that must be managed carefully. The size of the deletion on chromosome 5 and the presence of additional genetic abnormalities can influence the severity of these symptoms. This variability underscores the importance of a personalized, patient-centered approach to care. Early diagnosis and interventions are crucial in managing CDCS. A multidisciplinary team of healthcare professionals can provide comprehensive support, addressing the unique needs of each individual with CDCS in a holistic manner. While these challenges are significant, there are therapeutic strategies in place and more on the horizon. With ongoing advancements in genomic medicine and a deeper understanding of the underlying mechanisms of CDCS, we are optimistic about the potential for improved treatments and outcomes for individuals with this rare genetic disorder. Currently, management of CDCS primarily focuses on supportive care and interventions. This involves a multidisciplinary approach encompassing physical, occupational, and speech therapy, as well as educational support and medical management of health complications. Each treatment plan is tailored to the individual's specific needs and challenges, aiming to enhance their developmental progress and improve their quality of life. But the horizon of therapeutic strategies for CDCS is expanding. The advent of genomic medicine has opened up new avenues for potential treatments. Imagine replacing or correcting the missing or malfunctioning genes in CDCS. That's the promise of gene therapy. It's a revolutionary approach that could potentially halt or even reverse the effects of the disorder. In addition to gene therapy, targeted pharmacological interventions are also on the table. These are drugs designed to specifically counteract the effects of the genetic deletion by modulating the activity of the affected genes or pathways. The goal here is not just to manage symptoms, but to address the underlying cause of the disorder. And then there's gene editing, a powerful tool that could allow us to directly correct the genetic deletion causing CDCS. With technologies like CRISPR, we could theoretically rewrite the genetic code, restoring the missing or malfunctioning genes to their normal state. But as promising as these technologies are, they are still in their infancy. They require rigorous research and clinical trials to ensure their safety and effectiveness. And that's where ongoing research efforts come into play. Researchers around the world are diligently working to unravel the molecular mechanisms underlying CDCS. Their work holds the promise of developing novel therapeutic strategies that target the root cause of the disorder, rather than just its symptoms. As we continue to unravel the mysteries of CDCS, there is hope for improved management and potential treatments. The future is bright, filled with the potential of scientific discovery and the promise of transformative therapies. For individuals with CDCS and their families, this could mean a better quality of life and a brighter tomorrow. Recent research has deepened our understanding of Cri du Chat Syndrome. We've seen the potential for novel therapies, from gene editing to targeted pharmacological interventions. These breakthroughs, fueled by relentless inquiry and innovation, offer a beacon of hope for improved quality of life for those living with CDCS. With continued research and understanding, we inch closer to enhancing the lives of those affected by Cri du Chat Syndrome. Stay curious, stay informed, and until next time, keep exploring the wonders of genetics.